it is more potential and electron acceptor. In other words, from the top to the bottom, it should become larger and larger, the delta E value. So I gave you some of the examples. You can look at the table. What is it in ADH2? Look at here. Minus 0.32. Sorry, it's minus 32. What is FAD? You look at here. Minus 0.18. What is FMM? You look at here. FES, FM, somewhere 0. That's 0.03. Ubiquinol 0.07. That's COQ. Okay. How about oxygen? Positive 0.82. So you can do a calculation. What is the delta G difference, delta E difference between the electron transfer from the NADH2 to oxygen? That is positive 0.82 minus 0.32. 2 minus becomes plus. That is positive 0.82. Add 0.32 equals 1.14. That's electron transfer energy value. Okay, so that's the reason why it's organized like that. Okay, now next question will become, why this is important for the bacteria cell? Because there is one theory talk about another way to generate ATP. So you always remember, why is they going to do a recycle? Going to do a transferring of these electrons? Because they want to generate ATP. ATP is an energy currency. How they do it? Once these electrons transferring, there is another guy going to go out. Is this guy. Okay, go all the way here. Will go out. And outside of the cell membrane system, they will create a very strong potential energy. It's called proton motive force. PMF. This is a potential energy. So H plus is proton. You should know about that. Did you ever see Young Sheldon, the movie? He likes to watch the episode is Professor Proton. That's a proton right here. Okay? Which means it's important. There's a potential energy. So, coupled with electron transfer from the top to the bottom, from the more negative chemical to the more positive chemical, at the end of the day is oxygen. This proton will be transferred out of the cell membrane and accumulated there. They will be actually accumulated. Then become what? A potential energy called the proton motive force. And once they accumulate too much, what are they going to do? They're going to go back. But once they go back, what they do? They will activate an enzyme called ATPase. The function of the ATPase is to activate ADP with phosphate and become ATP. And for bacteria, not only for that, they find they are doing flagellar rotation. It's very interesting because flagellum rotation tell us it's a real bacterial movement. This is a whole theory which is comes out by a great British scientist, Peter Mitchell, in 1932. And later on in 1950, this is a Nobel Prize. The whole name called chemoosmosis. That one of the theory to talk about ATP generated through electron transport chain. Therefore, we call this oxidative phosphorylation. Okay? Oxidative phosphorylation. That's what it is. And you can see well explained right here is the slides. Okay, when you see the slides here, you have a chemoosmosis. And first of all, the electron is transferred. The electron transferring at the same time, the proton will be repelled out of the cell membrane system and accumulate there. Now, of course, there's a lot of the enzyme. For example, there's a dehydrogenase coming from the NADH2, so you're going to repel those electrons out of the cell membrane, then they're going to be, those protons out of the cell membrane, they're going to accumulate there. They become a potential energy for the proton motive force. And this proton motive force will be activate ATP synthesis. Why they can do that? Because at the end of the day, it's accumulated too much, they're going to come back. And this type of the channel is actually a protein which is across the cell membrane system. So we go back to see the fluid mosaic model is very magic, and then they come back. And usually what happens here is what I talked about in the first class, is that one peripheral protein there usually is a location for ATP next, and then ADP will become ATP. And because he is using bacteria as units to do the research, so he find not only generate ATP, the flagella will do the rotation will do. Because the flagella rotation is indicating real movement, so that's why this is a very important theory in the bacteria to talk about how the ATP generates through electron transport chain. Okay? It's very important for this section. Okay, limited time left, so we could be, you can read through all these again. And this is an important slides we'll talk on Thursday. You can see these are the electron carrier, and we'll talk about these again as a review material. Okay?